Hey guys, so today I'm going to be explaining to you guys about homozygotes and heterozygotes and how to do a dihybrid cross. So let's start with what is a homozygous? Homozygous basically means you have two of the same alleles. So for example, you have an AA allele, two alleles. One is capital A and the other is also capital A. So what makes this homozygous is the fact that they're both the same. They're both capital A's. They're both, for example, if A represented hair, right? And brown hair was the capital A, being brown. And you have both of them being the same thing, both of your alleles being the same, whether it's capital A, or whether it's lowercase a, that means it's homozygous. Okay? So then let's say lowercase a is for blonde. Okay. That's kind of horrible writing, but it's okay. So homozygous basically means that both of your alleles represent the same thing, which might be both brown hair or both might be blonde hair. That's essentially what it means to be homozygous. What does it mean to be a heterozygote then? Heterozygote means you have one dominant trait and one recessive trait. So essentially, your parents, somebody along the line, had that recessive trait and they passed it on to you. So what does that mean? That means you have one of each. Which one is shown is the question. Well, the one that's going to be seen by the general public, it's not like you're going to see both this and this, or you're not going to see both blonde and brown hair present. No, obviously not. You're only going to see the dominant one, which in this case is brown hair. So we're going to see brown hair on the person, but in reality, what we can't see is the fact that their alleles are actually different. So essentially, they are a heterozygote, meaning that they have one of each. But we would never be able to determine that by just looking at someone. Okay, so how do you do a dihybrid cross? Dihybrid cross is essentially looking at two different traits. So for example, hair and eye color. So it's looking at two different traits. Not just one trait, but two traits, okay? 1, 2. And basically what they're saying is that your dad and your mom were heterozygotes for both hair and eye color. Okay? So your mom has the heterozygote alleles for hair, and let's call B eye color. Uppercase B will be brown eyes, and we'll call the other one lowercase blue. Okay? So you got your mom, we'll call this mom. Your mom has AA, BB, one lowercase, whatever. And then your dad, he's also heterozygote for both hair and for eye color. So essentially what you're going to do is grab one of your parents, right? And you're going to think of all the different combinations that you could have by having this parent. Well, you could have uppercase A, uppercase B. You could have uppercase A, lowercase b. You could have lowercase a, uppercase b, or you could have lowercase a, lowercase b. Then what you're going to do is you're going to look at your dad and say, what are the different possibilities that my dad could have? Well, he could also have the exact same one. So AB, capital A, lowercase b, lowercase a, capital B, or lowercase a, lowercase b. Then what you're going to do is you're going to match these up and you're going to essentially add them together. So AB, AB, I'm not going to write down, I don't think I have enough space. So AB, AB, you would turn out with AB, AB. Essentially is the point, okay? Or if you match this one and this one, you're going to get both uppercase A's, one uppercase B, one lowercase b. Do you see my point? So one thing you're going to see then when you do that is you're going to see, you probably heard in your class about this 9:3:3:1 ratio. And you're probably like, where in the hell did that come from? A 9:3:3:1 ratio. Essentially what they're saying is the chances are 9 out of 13, because there's 9, 12, oh wait, never mind, 9, 12, 15, 16. So they're saying 9 out of 16 chance that you're going to have brown eyes and brown hair. You're going to be like, well, why is this the case? Because, first of all, because anytime you combine this uppercase A with any lowercase a, the one that's going to be represented, like we said earlier, the only one that we see to the naked eye is the one that's dominant. We only see the uppercase one, right? So there's so many possibilities of that happening. The only chances you're going to see of that not happening is if you're matching a lowercase a on this side, which is like these two, with another lowercase a, which would be like these two. So that's like only those possibilities. Those are like the only chances you have of having, what's it called? What was it? Brown hair? Yeah, or blonde hair. That's the only chances you really have of having blonde hair. So basically, what they're saying is 9 out of 16 times you are gonna have brown hair and brown eyes and hair. And essentially, what they're saying is 3 out of the times, and this 3 as well, you're gonna have one of each. So you could have, for example, brown hair and blue eyes, or you could have, really difficult to type on this computer, but it's okay. Or you could have blonde hair and brown eyes. So they're saying that there's a 3 out of 16 chance that you're going to have one of the recessive traits and then one of the dominant traits, is essentially what they're saying. Now, 1 out of 16 chances out of when you do the dihybrid cross between 2 heterozygote parents for 2 different traits, there's a 1 out of 16 chance that you're going to get both blue eyes and blonde hair, which is why you see it being so rare for people to have this. Okay? So basically, essentially, that's what a heterozygote is. A heterozygote basically means that they have 2 different alleles, so a capital letter and a lowercase letter, or a capital letter right here and a lowercase letter right here. That's a heterozygote. A homozygote would be if your mom had double A, uppercase. That's a homozygote. And what's a dihybrid cross? It's when you grab 2 people with heterozygotes on 2 different traits, one for hair, one for eye color, 2 different traits, and you mix them together. And this is your ratio, 9, 3, 3, 1. And what do each of them represent? Well, 9 represents the 9 out of 16 chance that you have of having brown hair and brown eyes. The 3 out of 16 chance that you have of having brown hair, blue eyes. The 3 out of 16 chance you have of having blonde hair, brown eyes. I forgot to write that, brown eyes. Or the 1 out of 16 chance you have of having blue eyes and blonde hair. Alright, I hope you guys understood that.